When nuclear energy has been successfully applied for power production, India will not have to look abroad for its experts, but will find them ready at hand.
These were the words of Homi Bhabha, the chief architect of India's nuclear program, scientist par excellence, institute builder, theoretical physicist, able administrator, policy maker, multifaceted personality, connoisseur of fine art. Homi Bhabha, a great visionary.
It shows the absolute necessity of finding some new source of energy if the light of our civilization is not to be extinguished because we have burnt out our fuel reserves. This would exhaust the known reserves of fossil fuels in under a century. It is in this context that we turn to atomic energy for a solution. I venture to predict that a method will be found for liberating fusion energy in a controlled manner within the next 2 decades. When that happens, the energy problems of the world will truly have been solved forever.
Bhabha dreamt for modern, self-reliant India, highly industrialized and technologically advanced. His solution was both simple and complex: ample electrical power for Indian modernization and industrialization. And he was far-sighted enough to predict the importance of nuclear technology towards this goal. Today, India is a nuclear power. Full credit for the establishment of India's nuclear research program and its nuclear weapons program must be given to Dr. Homi Bhabha. He ensured that India's own atomic energy development program progressed to a stage where atomic weapons could be produced in the country without external aid if called upon to do so.
I seriously say to you that business or a job as an engineer is not the thing for me. It is totally foreign to my nature and radically opposed to my temperament and opinions. Physics is my line. I'm burning with the desire to do physics. It is my only ambition. I have no desire to be a successful man or the head of a big firm. There are other intelligent people who like that, and let them do it. I, therefore, earnestly implore you to let me do physics.
This was a letter written by an 18-year-old Homi Bhabha from England to his parents in India. Homi Bhabha was born on 30th October 1909 in a wealthy Parsi family of Mumbai, having a long tradition of learning and service in the field of education. His grandfather was the Inspector General of Education in the state of Mysore. Bhabha's father, Jehangir Bhabha, was an Oxford alumni and a lawyer. Dr. Bhabha's paternal aunt, Meherbai, married Sir Dorabji Tata. Bhabha attended the Cathedral and John Connon School in Bombay. After passing senior Cambridge examination at the age of 15, he entered the Elphinstone College in Bombay and later the Royal Institute of Science. He was not much interested in sports but was absolutely brilliant in studies.
When Homi finished school, he was put by father into the Institute of Science. Then it was called Royal Institute of Science. And there he soon found that he was being taught what he had learned 2 years earlier at school.
At the age of 18, Dr. Bhabha left for England to pursue higher studies at Cambridge to study engineering. In 1927, Bhabha joined the Gonvere and Caius College in Cambridge. He took the Mechanical Sciences Tripos in 1930.
Homi at that time said, I want to strike a bargain with you. You will get your first class from me on the condition that you will finance me for 2 more years to do the mathematics tripos.
After passing the mechanical tripos with first class, Bhabha passed the mathematics tripos 2 years later. Bhabha was taught by Nobel laureate Paul Adrian Maurice Dirac, the Lucasian professor of mathematics at Cambridge and an authority in quantum theory. Later, Bhabha joined the Cavendish Laboratory. Bhabha held Salomon's studentship in engineering during 1931-1932. During 1932 to 1934, he held the Rouse Ball traveling studentship in mathematics. He traveled in Europe and worked with Wolfgang Pauli in Zurich. In January 1933, Homi Bhabha received his doctorate in nuclear physics after publishing his first scientific paper, The Absorption of Cosmic Radiation. The paper helped him win the Isaac Newton Studentship in 1934. In early 1934, he went to Italy to work at Enrico Fermi's Institute of Physics in Rome. During this period, he mostly worked in Cambridge, except for a short period when he worked with Niels Henrik David Bohr at Copenhagen. At Cambridge, Bhabha's work centered on cosmic rays. The most important of the papers that Bhabha wrote in positron physics is the one dealing with what has come to be known as Bhabha Scattering, which is Bhabha's crowning achievement in the area of positron physics. Bhabha Scattering revolves around exchange effects in electron-positron scattering.
It was believed that matter and antimatter, namely electron and positron, when they come together will annihilate each other. But Dr. Bhabha was the first scientist to realize that something else could also happen, namely scattering, which in his honor today is called Bhabha Scattering.
Watching two white billiard balls collide, we were able to say which ball went where, even though the balls look identical. This is because we are able to follow the trajectories of the individual particles. Scattering, as the very name implies, throws off the incident particles in various directions.
Faith in the formula is so much that is used routinely as a calibration for other scattering cross sections and provides the precise value for other cross sections which are measured at labs at CERN and other places.
Bhabha also explained the cosmic ray shower formation in a paper published in 1937.
Bhabha and Heitler were one of the first people who did extensive calculation of what the development of shower would look like and what will be its detailed properties.
The charged particle, as it travels down, releases a high energy gamma ray, and the gamma ray multiplies into an electron and a positron. And then again, these things annihilate and produce more gamma rays.
Interestingly, when Carl David Anderson discovered a new particle in the cosmic radiation with a mass between that of electron and the proton, he named it mesoton.
Bhabha had predicted on the basis of his analysis that there should be a particle of intermediate mass between the proton and the electron, and that turned out to be the case with the mu meson.
Today, however, this particle is known as muon. And even now the study of muon is providing us with very important insight into the functioning of the solar system. Bhabha was on a vacation in India in 1939 when World War II broke out in Europe. During this enforced extended holiday at home, he was deeply affected by the turbulent period at the dawn of the independence.
He was looking for a position to stay back in India for some time. He was offered many professorships. One of them was in Allahabad University, which he did not take up.
In 1940, Bhabha joined the Indian Institute of Science at Bangalore as reader. Here, at that time, Chandrasekhar Venkataraman was heading the physics department. In 1941, Bhabha was elected the Fellow of the Royal Society London, Dr. Raman being one of the proposers of his nomination. He wrote the thesis titled The Theory of Elementary Particles and Their Interaction, for which the Adams Prize was awarded in 1942. In the same year, he was promoted to a full professorship in cosmic ray research at the IISc. At Bangalore, Bhabha initiated experiments to study the so-called hard component of the cosmic rays. But even the basic equipment for the purpose was not available, so Bhabha decided to build the devices indigenously. A unique Geiger counter telescope was used by Bhabha. It is made of 4 Geiger counters with lead shield in between.
He built a Geiger counter telescope for cosmic ray research and took it up in that B-29 aeroplane to various altitudes.
Homi Bhabha measured the cosmic ray intensity as a function of altitude and latitude. To achieve the high altitudes, rubber balloons were not available. A balloon flights group was set up and then experiments were done in the penetrating component of cosmic rays at various latitudes. High-energy cosmic rays are the highest energetic particle which are coming on the Earth. This particle, when they enter the Earth atmosphere, they interact with the various nuclei present in the atmosphere and form extensive air shower. We study and try to find out what was the origin of the cosmic rays.
We have installed 400 plastic scintillation detectors. In addition to that, 3,712 proportional counter have also been installed, which have been shifted from the old Kolar Goldfield experiments, and they have been used here as a muon detector. It makes it the world's most sensitive and the largest muon tracking telescope.
Bhabha also built a 12-inch diameter circular cloud chamber to study the scattering characteristics of mesons. The cloud chambers are a very important device to visualize the propagation and interaction of high-energy particles. In the early 1940s, when Bhabha was working at the Indian Institute of Science, there was no institute in the country which had the necessary facilities for original work in nuclear physics, high-energy physics, cosmic rays, and other frontiers of knowledge in physics. On 19th August 1943, he wrote an informal letter to J.R.D. Tata.
Lack of proper conditions and intelligent financial support hamper the development of science in India at the pace which the talent in the country would warrant. It is one's duty to stay in one's own country and build up schools comparable with those in other lands.
J.R.D.'s reply was encouraging.
If you and or some of your colleagues in the scientific world will put up a concrete proposals backed by a sound case, I think that there is a very good chance that the Csir Tata Trust will respond.
This prompted him to send a proposal in March 1944 to the Sir Dorabji Tata Trust for establishing a vigorous school of research in fundamental physics, which was accepted by the trustees. With Bhabha as director and Kosambi as founding research faculty, Tata Institute of Fundamental Research started functioning officially on 1st June 1945 in Indian Institute of Science at Bangalore. During 1947, Bhabha also became member of two important scientific committees. First, the CSIR Review Committee, and secondly, the Scientific Manpower Committee under the chairmanship of Bhatnagar. This was a time when India arose to freedom. This was the time to do big, to dream bigger. On 26 August 1947, the CSIR set up a board of research on atomic energy. Bhabha was appointed its chairman. Guided by the able leadership and passionate perseverance of Dr. Bhabha, TFIR kept growing in size and stature to be counted as a center of excellence in fundamental research in physics and mathematics, epitomizing a new dawn in India.
He was not interested at the beginning about building infrastructure, but rather in selecting the very best people he could find for the job.
This was the beginning of a thriving legacy. Bhabha invited Professor Chandrasekharan and asked him to set up mathematics group in TIFR. In few years, this group became world famous.
He himself was interested in specific areas of mathematics. In fact, he started on a book which is incomplete, a book on spinors, which is a mathematical book.
Dr. Bhabha wanted TIFR to support diverse disciplines in pure science. Work in the field of radio astronomy was initiated in the TFIR. A unique radio telescope was developed in Ooty. It had a parabolic cylindrical reflecting surface, 530 meter long and 30 meter wide, placed on a hill, whose slope of about 11 degrees in the north-south direction is the same as the latitude of the station. This makes it possible to track celestial objects for about 10 hours from their rising in the east to their setting in the west by simply rotating the antenna mechanically along its long axis.
I was planning various instruments. At that time, radio telescope with 50 meter, 100 meter, 30 meter had not been built anywhere in the world or conceived even. I wanted to know Bhabha's opinion. He grilled me for 1.5 hours. He said, well, if it's inclined, how will it, axis will go down, will it fall down? Fortunately, I had thought about it. And I said, well, shall I write a proposal? He said, young man, don't waste your time. Form a group. Once you've formed a group, we'll approve your project.
Another important activity of TIFR under Dr. Bhabha was the design and development of the first electronic digital computer to be built in India. It was named TIFRAC and commissioned in February 1960. TIFRAC was used extensively for scientific purposes. Many scientists came and were trained on this computer, and it had serious influential role in the development of computer technology in the country. When tools for research were not readily available, Bhabha did not hesitate to support their development.
Tata Institute of Fundamental Research had a workshop which was as good as any workshop. And all of us, I worked in the workshop myself, in building instruments.
Another area in which the TFIR excelled was in the field of molecular biology. Under Obaid Siddiqui, the molecular biology work was initiated.
His legacy is that fundamental research was of absolute necessity for India. Research that had to be global in its character. It had to be amongst the best that could be done anywhere. We had to add knowledge to the sum total of knowledge of the whole world.
On April 26, 1948, Bhabha sent a note to the then Prime Minister of India, Jawaharlal Nehru.
The development of atomic energy should be entrusted to a very small and high-powered body composed of, say, 3 people with executive power and answerable directly to the Prime Minister without any intervening link. For brevity, this body may be referred as the Atomic Energy Commission.
The Government of India accepted Bhabha's proposal within a few months after its submission, and with the promulgation of the Indian Atomic Energy Act 1948, the Atomic Energy Commission was formed in August 1948. Right from the start, Bhabha seems to have conceptualized a comprehensive program for the development of atomic energy, extending over a wide spectrum. At one end was fundamental research in nuclear science and mathematics, aimed to make available sufficient manpower indigenously.
One of the fundamentally important decision taken by Homi Bhabha at that time was our concept of training school in BRC. 1957, this was one of the first steps, first batch of training school of scientists came out, and since then we have been continuing that tradition.
The work of the AEC started almost from scratch. Exploration activities related to atomic minerals like uranium and thorium-bearing ores were being organized.
One of the first divisions in atomic energy that was formed is Atomic Minerals Division. It was followed by other minerals. IREL was formed, and also UCL was formed for exploration of minerals. And along with that, detectors was one of the first things that started development in India. Our ECIL, Electronic Corporation, it was one of the first establishment of such large size, and as early as in 1960s it came up.
At the same time, research in nuclear power related subjects like chemistry, physics, engineering, biology, metallurgy, electronics control instrumentation was started on a small scale. TFIR was the natural base for such research activities. Bhabha realized that technology development for the atomic energy program could no longer be carried out within TIFR, so he decided to build a new laboratory entirely devoted to this purpose on 1200 acres of land at Trombay near Bombay. As the first step in power generation, it was decided to build a 1 megawatt swimming pool type reactor at Trombay.
All the components were made in India. I personally was responsible for a number of these large aluminium fabrications, they're quite unique in their design and construction. And then we got some of the components made in the Mazgaon dockyard. And very importantly, things like neutron detectors were made in the Tata Institute of Fundamental Research by our research scientists. Electronics, very important, was designed and built under the leadership of Mr. A.S. Rao. So his thrust was make everything that you can in this country.
The assembling was started in 1955, and within a year it was commissioned. It attained criticality on 4th August 1956. It was the first nuclear reactor in Asia and named Apsara by the then Prime Minister, Mr. Nehru, at the time of inauguration. Meanwhile, responding to Bhabha's plan to build a bigger experimental reactor, in 1955, a generous offer came from the Canadian government for the NRX Type 40 megawatt reactor. This offer was accepted and the construction started in 1956 and took about 4 years for completion. This reactor, named as Csir, an acronym for Canada-India Reactor Utility Service, is still operational.
Dr. Bhabha felt that any new reactor that we got should be capable of being fueled within India. And so the Csir reactor, which Canadians agreed to build here, uses natural uranium. And the very first charge of uranium fuel did not come fully from Canada. Dr. Bhabha persuaded the Canadians to accept that half of that fuel would be made in India.
With Apsara and Csir functional, Bhabha wanted to construct a 100% Indian reactor, Zalina, a zero-energy research reactor. With this new-founded talent pool and confidence, India initiated its journey towards commercial atomic power generation, starting from Tarapur. Dr. Bhabha sought to achieve a balance between indigenous development and international cooperation. He negotiated the setting up of reactor at Tarapur on a turnkey basis to demonstrate our willingness to take a recourse to international trade in commercial nuclear power.
In those days, not even a bicycle was being made in India. Not even a sewing machine was being made in India. So to be able to build a nuclear reactor on our own was a great achievement.
In 1954, he was honored with the Padma Bhushan, the third highest civilian award in India, for his invaluable contributions to science and engineering. Bhabha was the prime nuclear diplomat of India in decades of 50s and 60s. Bhabha played a decisive role in shaping the statutes of IAEA and then in drafting the initial program for it. Dr. Bhabha's leadership of the atomic energy program spanned 22 years.
We have a 3-stage nuclear program, nuclear power program, which was initiated by Dr. Bhabha. First stage, pressurized heavy water reactors using natural uranium as fuel and heavy water as moderator and coolant. Second stage of our program is to build fast breeder reactors. They are called breeders because they produce more fuel than they consume. Third stage, which he had envisaged, was to use thorium in these fast breeder reactors. So thorium gets converted to a very useful nuclear fuel, uranium-233. So what he had envisaged during his lifetime, and that is a program which still continues to be valid in our nuclear system.
India is likely to be a pioneer in the use of thorium because our first prototype thorium utilization reactor of about 300 megawatts will go into operation 7 or 8 years' time. And I think the world will then think of Dr. Bhabha as a true pioneer in forecasting the potentiality of thorium as a source of energy.
Dr. Homi Bhabha supported Dr. Vikram Sarabhai in setting up the first rocket launching station in India at Tumba, near Thiruvananthapuram. The inaugural flight was launched on November 21, 1963 with a sodium vapor payload. Bhabha did everything in impeccable style. He was a man of both the worlds in double sense, a man of science and that of arts. Bhabha did a large number of paintings, drawings and sketches which were praiseworthy by professional standards.
Homi, I'll tell you, was a very brilliant scientist, but a very brilliant draftsman. The drawings of Michelangelo, Leonardo da Vinci, were so good, and his drawings are even now top class.
Dr. Bhabha was passionately devoted to all forms of arts. For him, the arts was what made life worth living. Bhabha acquired the paintings of leading painters and had them tastefully displayed at TIFR. In fact, nobody writing a history of modern art can write it without visiting the TIFR collections. TIFR was the only customer in those days for the greats of Indian art, like Hussain, Ara and Gaitonde and others. Bhabha was the one who would buy their pictures. Bhabha was perhaps born with an ear for music. His parents had noticed early that switching on music had an instant effect of calming down the crying baby. Bhabha's love for trees and garden is quite well known. Bhabha wanted to make Trombay the Versailles of scientific world. Bhabha never considered landscaping a luxury. He passionately worked on the planning, design and style of gardens. Bhabha not only paid attention to the geometric form of the buildings being made, but also for which purpose they were being built.
The Tata Institute building itself has been described by some of the visitors as the most beautiful scientific building they had ever seen in the entire world. And he certainly wanted to bring beauty into whatever he looked at.
His grasp of architecture was very good. These aluminium windows, for example, first time were made for TIFR. Building should be said that it's excellent for research. Looks good, but functionally good, as well as up to date.
On January 24th, 1966, Dr. Bhabha was on his way to Vienna to attend a meeting of the Scientific Advisory Committee of the International Atomic Energy Agency. Dr. Homi Bhabha died in an air crash near the famous Mount Blanc peak of the Alps. It was a sad and untimely death. The whole nation was shocked, especially the scientific and the political world. Great people are remembered for their outstanding achievements. Similarly, Dr. Bhabha's achievements were in many dimensions. Bhabha is no more, but his work lives. Dr. Homi Bhabha spent his whole life in pursuit of grand vision based on self-reliance to steer India's scientific destiny. Today, our capabilities, particularly in nuclear science and engineering, are being recognized world over.
What he always emphasized was, don't do very safe science. Don't just sort of push the envelope a little bit. Try to do important science. Try to do creative science.
Homi Bhabha was a scientist of great originality, a visionary with relentless energy and drive to convert his vision into reality. What he could achieve in a short span of time was beyond ordinary human capabilities. Seldom does one come across a person so versatile.
I love the consciousness of life and I want as much of it as I can get. But the span of one's life is limited. What comes after death, no one knows, nor do I care. Since therefore, I cannot increase the content of life by increasing its duration, I will increase it by increasing its